This webcast continues Worksheet 7F, looking at problem 7. So in this problem we have 4 masses, and we want to find the net gravitational force. That means the sum of all of the gravitational forces on mass A. I'm going to circle A just so that I keep that in mind. The first thing you want to do in a problem like this is find all the forces on mass A, right? So I'm going to do a little force diagram here. And just one at a time, I want to consider each of the other 3 masses and what they would be doing to mass A. B is to the left of A. Gravitational force always tries to pull objects closer together. So B is going to try to move A closer to B. And so therefore, the gravitational force on object A by object B would point to the left. Don't get confused here. Don't ask yourself what A is doing to B. We want to know what is being done to A. Okay? The force of gravity on B by A would be going the other direction. And so it's important to think, what's happening to A? How is B pulling A? Okay, let's do the same thing for C. C is down at the diagonally at the other corner from A, and so it's going to try to pull A down there closer to C. This is the force of gravity on object A by object C. Similarly, D is going to try to pull A closer to it, so this is the force of gravity on A by D. Okay, so we have all of the forces. We're going to need to know the angles in standard position of these forces. Now, for the first force, the one that B is exerting on A, well, I know that that angle is 180 degrees, right? Because in standard position, you start on the positive x-axis, and then you rotate counterclockwise until you run into the vector. This angle for the force that's being exerted on A by C is somewhere in the middle of the third quadrant. To find that, I really need to look at, I need to find this angle. I'll call this alpha. Alpha is the same as this. This is alpha over here. So let's see, I know the sides of this rectangle, and so alpha, the tangent of alpha would be the opposite over the adjacent, or alpha would be the arctan of that 15 over 30. So I'm going to do the arctan of 0.5, and I get 26.57 degrees. So therefore this angle that I've colored in green is 180 plus 26.57, which would be 206.57 degrees. And then let's find another angle. I'll use orange for it. This angle is going to be 180 plus this angle here. Uh-oh, I didn't draw that in. I'm sorry, let me draw this. Plus this angle here. I don't know, I'm running out of names here. Maybe I'll call this beta. So the tangent of beta would be the opposite, which is 15 divided by 15, right? Because this angle is this length is 15, and this distance is 15. Okay, So the arctan of 1 is 45 degrees. Okay, so this is 180 plus 45. This orange angle is 225 degrees. Okay, so for each one of these forces, I know the direction that it is pointing by having it. So the next thing that I want to do is to set up, oh, the table is already set up for me here. I've got a table where I've got each of the forces, a place to find the magnitude, a place to write the angle, and then to find the components in the x and y directions. So for the force that's being exerted on A by B, that's at an angle of 180 degrees. The magnitude would be G times the product of the masses. Let's see, mass A is 80 and mass B is 100. And their distance, it looks like it's 30 meters. And of course I want to square that. So let's see what we get here. And so I get 5.929 times e to the negative 10th. That is all x component, right? And it's in the negative direction. There is no y component since it's at 180 degrees. You could always use your calculator if you're not confident that the cosine of 180 is negative 1. Okay, let's find here the next force, which is the force that C is exerting on A. So the mass of A is 80. The mass of C is 110. And I have to find that distance. That diagonal is going to be the square root of 15 squared plus 30 squared. And of course I want to square it. All right, I did that right, okay. So if we did that, I get 5.217 e to the negative 10th. Now this one is at an angle of 206.6 degrees. So I'm going to say that amount times the cosine of 206.6 is negative 4.665 e to the negative 10th. That's the x component. The y component would be that magnitude times the sine of 206.6. And so that's also negative 2.336 times 10 to the negative 10th. Okay? And then the last force is the force that D is imposing on A. So the mass of A is 80. The mass of D is 50, and then that diagonal between D and A is the square root of 15 squared plus 15 squared. And of course, then I want to square that. Okay. And so I get 5.929 e to the negative 10th. This is at an angle of 225. And so the x component is negative 4.192 e to the negative 10th, and the y component is going to be the same thing, right? I mean, I could always put that in my calculator, the magnitude times the sine of 225, but it's a 45, 45, 90 triangle there. Okay, so I have all of the components of the forces, and now I want to add them. So the net force is, and this is the gravitational force, I'm going to add all of the x components, and then I'm going to add all of the y components. So I get negative 1.479 e to the negative 9th. And then I'm adding the y components. Okay, I get negative 6.528 e to the negative 10th. Okay. That is the sum of all three of those forces, but this problem wanted us to give the answer in polar notation, and so I just need to take this information and find the magnitude and the angle. The magnitude here would be the square root of the x component squared plus the y component squared. And I get 1.616 times 10 to the negative 9th newtons. And then the angle is going to be the arctan of the y component over the x component. I see that both of these components are negative, so this is a net force that's pointing down in the third quadrant. And so I need to add 180 degrees to the value that my calculator is going to give me. And that's because it's in quadrant 3. Okay, so I'm going to do the arctan. And I get 203.82 degrees. And so that net force of gravity in polar notation is 1.616 times 10 to the negative 9th newtons, and it points at it in a direction of 203